You know, we can find the volume of a cone though. So why would we do this? And my response is, can you do this volume? This is the volume of the area under the function y equals the square root of x, and this is just a simple case. So this area here, if you took that area under y equals the square root of x and you rotated it around the x-axis the whole way around 360 degrees, you would create this shape, whatever that is. Turn it sideways, it looks a bit like a goblet or a wine glass or something. You create that shape. How do we find the volume of that shape? That's the question. So we can calculate the volume of a 3D shape using the same principle. And the principle, the formula, is this. So let's do it. The volume is equal to the integral between 4 and 0, that's my x boundaries, of, I'll put pi out here, pi y squared dx, which of course is equal to pi times the integral of between 4 and 0 of the square root of x dx, squared dx. Now I know I'm killing you, I'm going so slow, and I'm going to continue doing that at least for the first one. And so I can square the square root of x, gives me 4 and 0 of just x dx. And now look at this, it's actually a really easy question. Pi times a half x squared between 4 and 0. And that's equal to pi times a half 4 squared minus a half 0 squared, which is 0. And a half 4 squared is 8, so it's equal to 8 pi. The volume of this shape here is 8 pi units cubed. How good is that? Mint. Now, let's carry on to example 2. Let's determine the volume generated when the green area is rotated about the y-axis. Now, we don't know this function, but it looks a lot like an exponential function. So we need to calculate the function first of all. We know a few things about the function. It passes through this point here, which is 2, 1, and it passes through this point here, which is 3, 0. Now, because it's decreasing over time, but it looks like it asymptotes at the x-axis, we know that it's a function in this form, y equals possibly a e to the negative kx. Negative k because it's decreasing, and a is the initial value. Now, the initial value in this case, if you put x equals 0 in, you'll get 3. So we know, first of all, that y equals 3 e to the negative kx. And we also know at x equals 2, y equals 1. So we get 1 equals 3e to the negative 2k, which means that 1/3 equals e to the negative 2k. Take a natural log of both sides, you get the natural log of 1/3 equals negative 2k, and therefore k is equal to negative a half log of a third. Now, just as a little aside, negative a half log of a third can be written as negative a half log of 3 to the power of negative 1. The power can come out, and we get a half log of 3, which I prefer. I don't know about you, I prefer that. So I'm going to write it as a half log of 3. And so therefore the function is y equals 3e to the half log, oops, that's an h, log of 3x. And I want to find the volume of revolution when this function is rotated about the x-axis. So let's go for it. It's the integral between 2 and 0, they're my given boundaries, 2 and 0 here, of the function, but the function y squared with respect to x. This is our volume. And so, of course, that's equal to pi times the integral 2 to 0. Y squared is 9 e to the log 3x. When you square, you double the power. And this is with respect to x. I'll bring the 9 out. So I've got 9 pi. And when I integrate e to the log 3x, I get e to the log 3x divided by log of 3 between 2 and 0. And that gives me 9 pi. Well, actually, I might write it as, because that log 3's come out, 9 pi over the natural log of 3. And then e to the 2 log 3 minus e to the 0, which is just 1. And I'll quickly put that in my calculator. And it's equal to 72 pi over log 3, or 205.89. Incidentally, this is 1 and this is 9. Play around with it and see if you can work out why. And that's why it worked out to be actually quite a nice value here. Anyway, that should cover you for part of 12D now. We haven't done it around the y-axis, which we're going to talk about in the next video. All the best.